Okay, so the building envelope. Let's talk about kind of a big change this time around in the code, which is air infiltration. First of all, two big deals. Number one, with regard to the thermal envelope, when we refer to air infiltration, we're looking at that we require the envelope to be sealed to limit air infiltration. As I mentioned earlier, if you add up all the cracks and gaps in a typical home, that can be equal to a window being open all day long. And that can be housefuls of air that we have to reheat every hour. So we have to have sealing methods between dissimilar materials and that allow for expansion and contraction. So the sealants and so forth that we use have to be able to expand and contract and allow for expansion and contraction between building materials. Also, all sources of infiltration shall be caulked, gasketed, weather stripped, or otherwise sealed with an air barrier material or suitable film or solid material. So when we think about the three barriers that we're often familiar with in homes, we have our weather-resistive barrier, which is required by code to keep out water. And oftentimes that weather-resistive barrier is continuous and can also act as an air barrier to reduce air infiltration, like your building wraps. And the third barrier we often refer to is what we call our vapor retarder. All right, so let's look at some sources. Number one, skylights, doors, and windows. They have to be addressed under this section 402.4.1 under air leakage. Openings between doors and windows, assemblies, and the jambs and framings, they have to be appropriately caulked and sealed. Any utility penetrations, anywhere we have any penetrations going through the envelope, they have to be sealed. Anywhere we have drop ceilings or chases, they have to be, that are adjacent to the thermal envelope, like we see here in this example, they have to be sealed as well. So it's important that we recognize that all these areas have to be sealed in addition to knee walls. Also, walls and ceilings separating a garage from conditioned spaces. In other words, any time that we have a conditioned versus a non-conditioned space, we have to seal those walls and ceilings. Also behind tubs and showers and exterior walls, as well as attic access openings. And another important area is rim joist junctions, where we have our floor joists intersect our rims around the perimeter of the house. Those are also very leaky areas. So when I look at the effects of air infiltration, air tends to infiltrate into the lower parts of the structure and exfiltrate out through the upper parts. That's because when warm air rises because it's more buoyant than cold air. All right. Now, a couple things that the code allows us to do. We have two options under the code. We can either do a blower door testing option, or we can do a rather elaborate checklist that can be filled out and inspected by the building code official, but the building code official can also request that the builder have a third party perform that inspection. So two methods to meet the air infiltration requirements under the code. One is the blower door test and one is the checklist. Now, with what we're looking at here is the blower door is basically a device that is a fan that fits in a doorway. And you turn on this fan, and the fan has some manometers that measure pressure differences. And through an algorithm and a computer program, we can take measurements about the airflow flowing through that house, do some simple calculations, and determine what the air exchange rate of the home is, or how many cubic feet of air per minute is flowing out of the house. And so there's some certain requirements that we have to follow to meet that. Now, the blower door test basically depressurizes the home using a large fan, and it basically is a way for us to determine two things. One, the overall leakage rate of the house. It also helps us to identify where those leaks are at. Now, the beauty of a blower door test option versus the option of just going through the checklist is that you could go through that checklist and miss a big hole somewhere and never really know why the house really wasn't performing as well as it could be in terms of its air exchange rate. So in general, the rule is that when the blower door testing is done, it can't be more than 7 air changes per hour at 50 pascals. What does that mean? We're talking about an air change per hour. That is basically a house full of air, or one full house full of air that's exchanged every hour between indoors and outdoors. Now, 50 pascals is the pressure difference under which this test operates. When we look at, in the United States, how we measure pressure, it's the English system, which is pounds per inch. But the metric system, which is what we use here, is in pascals. So this 50 pascal pressure difference, to give you an idea of how much pressure difference there is across the building, it's about that of a 20-mile-an-hour wind. And the reason why one of the reasons why they chose that number is to have a number that created enough of a pressure difference to get accurate measurements with the blower door. Because keep in mind that every home is different, and so you could have some homes that are fairly tight, some homes that are fairly leaky. So they tried to develop this equipment and test protocols to be as common sense as possible and to have as most accurate results as possible. But the key thing to remember here is that air leakage can account for a large amount of the total energy loss in a home, and that's why the code has these two options, the inspection option, checklist, as well as the blower door. Now, the checklist option, it looks complicated, but it's really not. Essentially what we're looking at is for air leaks and also how that insulation is installed. So we're looking at attics and ceilings, we're looking at walls, we're looking at rim joists, we're looking at the interfaces between shower tubs and exterior walls and fireplaces, between windows and door jambs and the frames around windows and the framing materials, with the goal to make sure that we seal up all these unnecessary cracks and gaps that not only lead to air infiltration and exfiltration, but also are pathways for warm, humid air to infiltrate into the wall system. Another important part of this checklist, it looks as to how insulation is installed. You know, the performance of insulation is directly proportional to how well it's installed, because when you compress insulation, it loses a lot of its R value. And so if insulation has gaps and cracks and voids, it's not going to perform as well. In fact, studies have shown that insulation that's installed improperly, its R value can be reduced by 30% or even more.
Quality installation is recognized as being so important that a grading system has been created that scores the installation quality. Grade 1 installation complies with manufacturer instructions. It completely fills all the cavity and is encapsulated on all 6 sides. Insulation is cut to fit around electrical boxes, split around wiring, and generally not compressed. Grade 1 installation is how insulation should be installed to meet the code requirements. Grade 2 is the middle grade. This installation shows some imperfections. You'll find moderate to frequent defects such as gaps around wiring, outlets, and plumbing, and as much as 10% of the insulation compressed. Grade 3 is the lowest grade and consequently the least energy efficient of insulation installation. A grade 3 insulation is not cut to fit tight and will have more than 2% of the insulation missing and more than 10% of the insulation compressed.
So this checklist is very important, so pay close attention to it. Now this checklist can be done by the code official. It can be done by, as requested by the code official. It can also be done by an independent qualified third party that's hired by the builder to go through this checklist, so the code official doesn't have to.
In any event, this checklist has to be filled out if a blower door test is not performed.